Hello, today I'm gonna show you how to create a parametric elevation like in this video. We're gonna use mass modeling, pattern-based panel and Dynamo. Create a new family, conceptual mass, metric mass. Let's draw the shape of our building. Go to the top view, pick line. I'll draw 4 segments, 900 centimeters, 300, 600, and an arc. Create a form from these lines. I'll set the scale to 1 to 20. Select all of the side faces and click Divide Surface. Choose the 1x2 step pattern. Set layout to fixed distance for both grids. Change the distance to 50 cm for the U grid and 25 cm for the V grid to get a square shape. Let's create a parametric facade panel. Go to the File, New, Family, and Metric Curtain Panel Pattern Based. Change the grid to 1x2 step. Set spacing to 250 and 500 mm. To see it better, I'll set the scale to 1 to 10. Create a point on the work plane and set this work plane. Place a point on each corner, choosing the work plane each time. So the second point, third point, I'll change the scale, and fourth point. Move points up using this handle. Here you can see an offset from point number 1. Move second point up. Move 2 symmetrical points down. Here we go. Now choose the point and middle point of the family and create a line. Do the same for symmetrical point and symmetrical side. Good. Okay, now choose all segments. Create a pattern line. I'll set the scale to 1 to 2. Now we have to create an offset parameter to these points. We need one parameter with plus and one parameter with minus. Go to the Family Type settings. Create a new parameter. I'll name it as an angle. It must be instance parameter. And change data type to angle. Now set the work plane to the pattern grid. Place and align dimension. Create a new parameter. I'll name it length. It has to be an instant reporting parameter. If you want to make a schedule, create a shared parameter. Go to the Family Type settings, create a new parameter. I'll name it as an offset. I'll give it a value, for example 2.5 centimeters. Now create another one parameter. It will be a leg parameter. It has to be instance. The formula is reported length divided by 2 and by tangents of angle. As you see, we have a distance there with plus. Create a new parameter. Name it as an angle leg minus. And also an instance parameter. Copy that formula and paste it with minus. Click OK. Choose these 2 points and use created parameter for them. Choose next 2 points and use minus parameter. Here we go. If we change our angle parameter, these lines will change angle too. Now we have to create panel border offset. Create a new point and place it on one of the lines. Use Draw on Face. Do it for the second one, for the third, and for the last one. Now we have to calculate our length from the middle point to this point. Go to Family Types and create new parameter. I'll call it as a panel length divided by 2 and its instance parameter. Formula is reported length divided by 2 and minus offset. Okay, now I replaced the point because I placed it wrong. Set segment length. Now measure from end and our panel length divided by 2 parameter. I'll place these points once again and again measure from the end, segment length and panel length parameter. And do the same for the last 2 points except of measure from beginning. Here we go. Connect these 2 points. Create a reference line. Same for these 2 points. And also a reference line. Place 2 points on the 2 sides of the line and 2 points on this line. Change measure from for the point with the longest curve parameter. And the same for this point. Choose 4 points we just created. Change curve parameter on segment length and apply our offset parameter. Now make a point based on a work plane. Set work plane and choose one of the points. Put there 2 points. Make it for every point we just created. Grab these points up and down. Now we have to create offset for these 2 points. Go to the family type parameters, create a new parameter, call it as a panel width, It must be a type parameter. Now create parameter panel wide divided by 2 and it's actually equals panel wide divided by 2. I will assign a value of 3 centimeters to the wide parameter and create negative panel wide divided by 2. Formula is minus panel wide divided by 2. Now let's apply its offsets for our points. 2 negative offsets and 2 positive offsets. And do the same for the second side. Good. Now draw a line. And you have to draw a line between every 4 points on every side. Select lines you just created. Make them as a reference lines. Now select these lines and create a form. Select this mask, click this button next to material by category, create a new material and name it as a panel material. And this is type parameter. Now we can go to the family type parameters and change material of the panel. I'll choose concrete, for example. Also, you can change an angle. So as you see, panel changed angle and material. You can set angle up to 89 degrees. And even 0 degrees. Okay, let's back to the 15 degrees. Also, you can change a height, for example, 5 centimeters. Or change offset, for example, 1 centimeter. Okay, I set 3 centimeters. We have a ready-to-use family. Now we have to save it and load into our mass. Select walls and apply family that we just created. I'll make it a little bit higher and I'll apply our created panel family again. Now go to the top view and create some reference planes next to walls. I'll name that plane 1 and create another one. Change a name on 2 and draw the last one reference plane and name it 3. Here we go. Now set the reference plane using one of the reference planes we just created and go to the elevation view. Just click OK here. Let's draw some ellipses. I guess it's enough. You can see ellipses on 3D view. Now go to the level 1 and set next reference plane. Go to the elevation view. Create some ellipses here. Very good. Now go back to the level 1. and set the last one reference plane as a work plane. And go to the sort elevation view. And I'll draw a couple ellipses there. Here we go. Go to the Manage tab and let's continue our work in Dynamo. Right-click to open Search menu. Find a Family Types node. Now find and note all elements of family type. Use it. Connect these nodes. Select our panel family in this list. Find and note element get location. Use it. Connect it with the previous one. If you run script, you get all panel locations. Now you have to add the node Select Elements. Element Geometry node. Connect them. Surface by path. Connect with Element Geometry. Find the List Flatten node. Surface by path connect with the list. Don't change the amount parameter in this node. Get a count node. Count number of our panels. Now get a cycle node. Count node results connect with the amount parameter. List flatten connect with the list. Now get distance to parameter to measure distance between our circles and our panels. Connect cycle list with other and panel geometry with geometry. Now find our math range. We will use it to recalculate our distance to angles. Connect distance result to the numbers. Get number node. Copy that. Connect numbers with the new min and new max. Closest panels have to be open, so new min is 89 degrees. For the new max, set value less than 0. Get the code block. Code is value less than 0. Connect remap range with the code block. Get the count node. Connect remap range with the node. Get the cycle node and connect amount with the count. Find a number node. Number has to be equal 0. Connect number with the cycle. Get if node. Connect code block with the test. Cycle list with the true. And remap range results to the false. Find a node. Element set parameter by name. Connect if node results with value. All elements of type to the element. And add a new code block. Right angle in quotation marks here. Connect it with parameter name. Now go to the Revit and isolate your ellipses. Go to the Select Model Elements node and click Select. Select your ellipses. Now we can reset elements isolation. And finally click Run. So we got amazing parametric facade for your projects. You can delete all ellipses that we used. Now little conclusion. We're getting all panels using family type, all elements of family type, and element getLocation node to get location points. For the reference elements, we drew ellipses, select them, and using element geometry and surface by path, create a reference planes. Made a list of them and merge using polysurface by join surfaces and multiply by the number of panels. After, we count the distance between ellipses and panels. And change distance to the angle using math remap range with minimum and maximum angle, and if node to get angle 0 for all the most distant panels. Thanks for watching my video. I hope this tutorial was helpful and good luck with your work.